Located within the Metrotech area of Brooklyn lies NYU's Makerspace, a workshop and lab for its engineering students to create the next innovations. Within its toolbox, the Makerspace houses 15 Ultimakers, a brand of compact 3D printers free to use by any student. 3D printing utilizes the process of additive manufacturing. The nozzle of the printer dispenses heated plastic filament into the printing bed to form an object over time, layer by layer.
There's many different types of 3D printing. The most common one is FDM printing, which is fused deposition modeling. That is where it takes a three-dimensional model file and it slices it, and then it takes a hot end, which it pumps plastic through to melt, and it puts that down one layer at a time, sort of building the process up from the bottom. That's how most 3D printers work. That's the Ultimakers and the Elites and Mojos that we have here in the space.
In order to 3D print an object, first the model must be built on a computer. The program used in this video is Autodesk's Inventor. Inventor allows the user to create a two-dimensional drawing and then extrude it to a 3D model. After the model is created, it is exported as a special stereolithography file into another program. In this video, Cura is used. Cura simulates the 3D printer and build plate restrictions and allows the user to place their 3D model into the bed and adjust its size, position, and orientation. After the model is placed onto the bed and its dimensions are adjusted accordingly, it is sent to the printer.
3D printing is most applicable to rapid prototyping. This idea of you have an idea for it and you want to get a prototype or a working model of the idea as quickly as possible. And so the 3D printers have allowed people to do that in a way that's never really been possible before. And to make things that before would have required extreme, or not extreme, but advanced technical knowledge, or at least access to a machinist and a machine shop that would have been outside the price range of most of our students. So this space gives our students the ability to quickly and accurately develop rough prototypes of things they're trying to design that they would have not had even 10 years ago.
While in the makerspace, the 3D printers are used locally amongst the student body for personal and school use. They are also used for rapid prototyping. This causation is used commercially as well, and is prominent within the automotive industry. 3D printing revolutionized the mass production of vehicles economically. Using printed parts to prototype new models and test new components, the value of the market is being boosted, with the average revenue from 3D printing amassing to about $600 million for 2014. The car in this clip, Strati, prototyped by Local Motors, is the first electric vehicle to heavily utilize 3D printed parts. Not only does it boast a quick production time of 44 hours, but also proves to be more economical with prices between $18,000 and $30,000, leaving the future of cars and automotives towards one focused on efficiency and affordability. Another application of additive manufacturing that focuses on affordability is housing. The housing market has been reinvented with the addition of 3D printing, with many construction firms, specifically Appriss Core, focusing on eradicating homelessness through the use of technology. This innovation provides a safe, affordable housing alternative to the market. The future of this application is expanding. While many of these developments are present globally, in Russia, Dubai, Amsterdam, and the United States, its scope is intended to reach further, to developing countries lacking adequate housing. Apart from commercial and humanitarian applications, 3D printing has made most of its advances in the medical field, most notably for organ transplants. Again, the efficiency inherent in the technology allows the scaffolding of organs such as livers, kidneys, and hearts. The mold for the scaffold is created using hydrogel and is created to replicate the organ being transplanted. Another form of 3D printing in the medical field is bioprinting. While similar to the hydrogel organ printing in design, bioprinting utilizes human cells and even living ink. Made of cellulose, living ink can be used when flexibility is necessary, specifically for skin grafts. Human cells are also used in the production of tissue and organ structures. While the methods of bioprinting have been praised for its innovation, the process has been met with a technological and ethical opposition. Many fear the actual success rate and safety of the procedure, which done incorrectly can result in the body rejecting the organ and in turn destroying the tissue entirely. In order to avoid rejection, stem cells must be taken from the specific patient. This method causes a hurdle in providing its safety due to the fact that you cannot test the process beforehand in a traditional manner. Each operation would be entirely unique, creating a similar amount of risk in each. The individualization of bioprinting also creates an ethical concern. This individual treatment comes with the exorbitant costs of similar innovations in stem cell research. This field of personal medicine has been shown to increase the disparity between the poor and the rich even further. With the cost burden on the patient, the lower income population will be barred from this world of innovation, leaving only the wealthy to benefit. Outside of the bioprinting realm, in 3D printing exists the problem of regulation, or the lack of regulation, regarding the use of personal printers. Most printed files aren't created by the owner of the printer, but downloaded from online sharing databases. Similar to how the internet's communal culture has led to problems in the filming and music industry, 3D printing poses intellectual property violations at a wide scale. With no protection for the files uploaded to popular websites like Thingiverse, theft of concepts is a major concern, especially with industry involving the selling of copyright-protected merchandise. For example, the action figure market has been met with an online database comprised of stolen characters available for all to take as their own. A video game developer under the name of Square Enix has filed numerous lawsuits over copyright violations online, including a case against digital artist Jacqueline Bolden, who is selling 3D models of their characters. While the service of directly buying the models has been seized, the opportunity to find the models' files online and print them yourself still remains. Another concern related to 3D printing is its environmental impact.
The environmental impact, of course it is using plastic, and so you could, there is a good amount of waste created in the 3D printing process through supports or RAM, adhesive structures that are printed along with it that are removed to make the print look better.
The two types of plastic used in 3D printing are PLA and ABS. While metals can be used, they are much more expensive and difficult to work with. At a study conducted by Illinois Institute of Technology, it was determined that PLA emits 20 billion ultrafine particles per minute, and ABS emits 20 billion ultrafine particles per minute. These emissions are comparable to a burning cigarette, with side effects including cancer. Because plastic is very inexpensive, it is used a lot more than other materials. ABS plastic, the most commonly used 3D printing material, is non-biodegradable. Recycled plastic is used in the creation of ABS and PLA filaments. However, a lot of unused material is left on the print bed and is wasted. The rise of this innovation has led us to question, what is the artificial's place in nature? Does the plastic byproduct that pollutes our waters belong here? Is there a home for the 3D in a world that has already been built? Do the 3D homes being printed globally belong in these environments? Will they adapt? Or will the environment have to adapt? As of now, it seems like the environment has been the one to bear the burden, the one to adapt to the 3D. What will happen to the man-made come the 3D revolution? Will our skyscrapers remain steel, or will they be replaced by 3D counterparts? Will the future be one of plastic? Can you imagine the city around you rebuilt by a printer? Will this be our future?